The assignment gave us a set of measurements or observation, and among those, the electrical energy output of the plant. The goal was to build a model to predict the energy output for the plant. Since the plant and the context was new to me, I also explored the internet to know more. I used a well-known library called Pandas that helped me to extract the data that was provided to us. The data was provided in a CSV file, and the library helped me to arrange the data in a table. From the extraction, we see that we received 9,568 observations from 5 different measurements. We can check quickly that all the values of the data are numerically filled and not invalid. We also double check if all the values respect the measurements limit to find eventual outliers that we shall not consider for our learning approach. For this problem, I chose as an output metric the mean absolute error and the mean absolute percentage error, which are output metric easily interpretable, but also the coefficient of determination, or R squared, that is used to communicate how much my model explained the variability of the single target. The first real challenge for me was the feature selection. Starting from the context that I tried to investigate online as well, the measurements provided are basically all important and impact directly the energy output. So a first naive answer would be to use all the measurements. I could not find a deep mathematical explanation in the online specialization module 1 on how to select the feature and why. So I tried to investigate online. I decided to visualize the correlation between the single target and the measurements with a correlation matrix. It is basically a tool that helps to identify and visualize pattern in the given data. We see from the last row or the last column that the ambient temperature has a better correlation with the target energy output. I also found it interesting to explore the sklearn Python library and identify a process that helps identify significant relationship between input and output variables with a score. In our case, for a regression problem, we can use the F-score. I cannot argument much on this subject because it's new to me, but I understood that the higher is the score for a feature, more confident we can be to use that feature in our model. The ambient temperature is confirmed to be the measurement with the highest score, with the strongest relationship between this input and the output energy among all the measurements provided. Moreover, a simple scatter plot highlights more a kind of a pattern between the ambient temperature and the energy output with respect to each of the other measurements and the energy output. Nevertheless, because I think this subject is not simple as it sounds and the technique that I'm using could be explored further in depth, there is a suggestion from this online course that state that including too few features is usually much worse than including too many. And since we are dealing with only 4 features, we could potentially include them all in our model building. The features could be selected from 1 to 4 features, but we need eventually to split the database received in a train and a test set. I decided to use 20% for the test set and split the training set into 2 subsets in order to compare different models. I chose the fixed validation strategy because it was simpler, even though I believe the k-cross validation could be more effective. We are facing a regression problem, and I chose 1 parametric and 2 non-parametric algorithms. The parametric one is called linear regression, and the non-parametrics are random forest and decision tree. The 2 non-parametric algorithms shall differ for evaluating the problem simple or very complex. Since I can explore algorithm as I like for my assignment, I left myself in the doubt if the machine learning problem I'm facing is very complex or not. I decided the coefficient of determination as output metric that will help me in selecting the model. The highest R-square or coefficient of determination score shall decide the model for me. Regarding the features, I did not have the final answer on how many features I should choose. We understood that the ambient temperature had a stronger relationship with the output, but at the same time, in general, using more features would be better than less features. And in this specific case, we're only talking about 4 features, so we could choose them all. So I decided to nest 2 loops. As an outer loop, I select the number of features, and as an inner loop, I train each model with that set of features. I gather the R-squared values and I plotted the result. From the result that we can see in the plot, I chose the random forest using all the measurements, which means using 4 features. Once the model is chosen, I take back my test set that was put aside for the model training and selection. I then use my model chosen, the random forest, to evaluate his prediction against the test set. I obtained 5.3% mean absolute percentage error from the predicted output of my model against the test set output. I also tried the second most performing model, the decision tree, with all the features, as a confirmation that with the test set performed worse than the random forest. From our modeling evaluation analysis, we concluded to select the random forest. We can now apply the chosen machine learning approach to the entire database.